We are in lesson 6-5 in Precalculus. Today's date is January 24th. Please put it on your papers 1/24. Today we're talking about permutations, not combinations. Those come tomorrow, but we are going to define combinations because we need to know the difference between permutations and combinations. So, permutation, order matters.
Order doesn't matter.
All orders matter.
They don't matter.
Order matters. For example, if I have a combination lock to a locker, it matters if I do 5, then 10, then 15. I can't do 10, then 5, then 15. That's not going to work. It has to be in the correct order. Do you agree? So think about locks. Locks are always permutation. What are some other things where order definitely matters? If I have a group of things, a group of numbers, a group of people, a group of food, when does order matter?
Your PIN for credit card.
Yeah, credit card pins. I would say your PIN number.
Your security number.
All these security things. I guess security is kind of being grouped into one category here. Another thing that matters is races. Yes, these 4 people finished in the top 4, but it matters who is first, who is second, who is third, who is fourth. It does matter the order for the race. Other things that matter. Arranging a line. Very similar to a race. If I have a line of 4 objects, what order does the line happen? What is another thing where order matters? Maybe we'll come back to this if we picture order.
Like it depends on when they were taken.
So dates, yeah.
Timeline, you mean? Timeline.
Timeline, sure. Timeline, order definitely matters. All right, combination. Where does order, the definition, what is it? If permutation was order matters, combination is order does not matter. Doesn't matter. Let me give you one example. Let's say I am at the pizza place and I'm choosing pizza combinations. Does it matter that I said pepperoni before pineapple? It does not matter. So, pizza toppings. I'm sorry. Let's choose something not food related. Let's say you're going to the store and you're buying clothing. Let's say you buy a hoodie first, shoes next. Does it matter when you're choosing your outfit? No, they're all going to be on you. So clothing. That's another.
Wait, when you actually dress yourself, do you first do your shirt or your pants?
Is this like a personal question, like
Well,
that actually
yeah,
matters?
I'm just asking.
I usually do shirt because I'm already wearing it for my pajamas. I'm wearing my pajamas underneath, so. But I guess my dress shirt I put on after my pants.
I usually do pants first and then.
It's efficiency. You transition smoothly from pajamas into work clothes. It's nice, right? I can show you my pajamas. They're blue.
Are you serious? Oh my god, you're serious.
Yeah.
So honestly, like
Efficiency in all things.
when you get home, you just take off your shirt, you're done.
Well, no, because my shirt is all stinky, and then I switch back to
Ew.
my pajamas.
Ah,
The whole point of wearing the undershirt is so I can keep wearing this multiple times without having to wash it, and then I wash it every 3 times.
That's very efficient though. Like,
Thank you. You
I
made my
like
day.
that. I actually kind of like it.
All right, so
Well, so you won't have to actually like clean your shirt.
Which
that
shirt?
out.
it's the reason we wear underwear. You can wear the same pair of pants because our skin that is gross is not touching the pair of pants. Same thing with undershirt. You wear an undershirt because the shirt on the outside does not touch the gross, sweaty armpits. Yep, yep.
Come on, Rochelle.
All right. That was a very
Anyway,
interesting
sorry.
aside. We can come back to combination later. Maybe tomorrow we'll define more things. But what is a factorial? And I forgot to put up our warm-up, but we can do our warm-up right now. That is the warm-up for geometry. Factorial. This symbol right here is read as factorial. So if I see 5 exclamation mark, you don't pronounce this as 5. You pronounce this as 5 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 2 times 1.
If it was 100 factorial, it would have been 100 times.
Oh my god, that would be a big number, yeah. So let's do this problem really quickly where I have 60 factorial over 58 factorial. We'll solve it together. So tell me how to write out 60 factorial. 60 factorial is equal to, you're not doing this for your notes.
60 times 59 times 58 times 57 times 56 times 55 times.
Oh my god, can't get it. Oh my god, number 9. Yeah.
So it always has to start with the actual number before the factorial.
Yes, always.
Okay. Okay.
And technically, you don't need to know this, but it's a cool little fun fact. 0 factorial is equal to 1,
So that's 0 times 1, right?
which is 0.
Wait, can you explain it?
What? It's a conversation. I need like at least 5 minutes to explain that one, and I don't have the time for today.
Take 5 minutes right now.
We already did too many tangents.
Wait,
Also, I'm scared that I
wanna
can't
know.
explain this very
is
well.
mathematics right here, alright? It's like
Well, if we have time at the end, I promise we will talk about it.
Think about it. For AP calculus, give us a
Think about
definition
Okay, anyway.
Sorry, there was a kid a few years. Was it last year, Jack?
Yeah.
That was his catchphrase. Just think about it.
Jack,
All right.
I really miss him. Jack!
We'll come back to it at the very end if we have time. 58 factorial. Well, this goes on and on forever, right? Goes until you hit 1. Do you agree?
Yeah.
How do I write 58 factorial?
58 times 57 times 56 times 55 times 54.
And it goes on forever and ever. You agree?
Yes.
Notice that when things are multiplied, they cancel each other out. Do I have a 58 on the top and the bottom? They cancel out. 57 on the top and the bottom?
Cancel out.
56 on the top and the bottom?
Cancel out.
Do you think there's a 2 on the top and the bottom?
Oh, yeah.
Those 2 that are not even there cancel each other out. In fact, all of this cancels each other out. And 60 factorial divided by 58 factorial is really just 60 times 59. That's it. Isn't that cool?
What?
Dividing factorials is my pleasure. It's so fun to just get rid of all of this math and you only have this tiny little problem left over. That's what we're doing today. This is today's math. We're dealing with division of factorials. It's fun. And I have an embarrassing secret to share with you too. I didn't know how to do this until my second year of college. They had these factorial. They had like 60 whatever factorial divided by 40 factorial, and I'd be like, get out the calculator. I couldn't do these by hands. You are already smarter than Mr. Sindel today. Boom. You know how to do factorial division. Yeah. All right. So, factorial, it's this symbol. Write it in your notes. Factorial is that symbol. So if you say 5 factorial, that's equal to 5 times 4 times 3 times 2 times 1. Not times 0, just ends at 1. So otherwise it would be 0, right? So 5 times 4 is 20. 20 times 3?
60.
60 times 2?
120.
120 times 1?
120.
120 is the answer of 5 factorial. Cool.
Honey.
And if you don't believe me, check this out. I go up to Spotlight Search, 5 exclamation point, 120. Boom.
Wait, do we have the actual like exclamation point on the calculators?
You do. So if you go to calculator on your phone, pull them out. Calculator. And on the calculator here, if I type in 5 factorial, it says X exclamation point. Boom. 120.
I never even saw that.
I know. Why is there punctuation here, Mr. Sindel? Where's the period in the comma?
There's no one here.
You might need to hit second or something.
Second.
Exclamation point somewhere. Factorial somewhere. No.
I got it.
You got it.
Here.
No, I'm just
Oh,
kidding.
that
I use this one.
Oh, yeah, so that one. Let me pull up that one. So on that one, second quit. If you're using this one, let's say 5 factorial, go to math. Boom. You go number, hit right. Oh, is it number? Uh-oh. It should be under math, maybe somewhere. Is it not in math? Where the heck is it? It should be in this menu. Probability. There it is. Go all the way to the right.
Oh, it's 4.
Yeah, 4. Boom. 5 factorial. Boom. 120. Cool, cool. So coming back here, repetition is allowed. So all of today's topic is permutation. Assume we're in permutation. By the way, this, what is the name for this thing?
Lock.
A lock. What type of lock? Starts with a C. Comma.
Wait.
Chameleon.
No, I'm just. Wait.
It's a chameleon lock, according to Daisy. It's green.
Combination.
Yeah, it's called a combination lock, which is weird. It's so weird. Look at this.
Oh, yell.
Order matters, though, for a combination
No.
lock. Order, locks, pin, race, order matters. This, a better name for this is a permutation lock.
What? No.
That's my brain exploding.
Head.
It's a permutation lock. If you call this a permutation lock for the rest of your life, I will smile at you forever and ever.
Mr. Chanel, once you are like old
Permutation lock.
and like wrinkly and everything, and I come by and
Look at this permutation lock, Mr. Chanel. And then, you know what I'm going to do? Yep, that's right. All right. Repetition is allowed. All right, so let's assume we have n choices. Let's assume we have like this, like a combination lock that looks like this. We have a number here, and a number here. So how many digits do we have in the base 10 system? In the base 10 system, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 options. So in our combination lock, we have a number here, and a number here. How many options do I have for that first number? 10. How many options do I have for the second number?
10.
How many options do I have for the third number?
10.
So how many options do I have for the entire lock? Do I add them or do I multiply them?
It'd be 1,000.
10 times 10 times 10 options. Which means I have one with 1, 2, 3 zeros. 1, 2, 3 zeros. And Rochelle is correct. That is 1,000 options.
See, I'm smart like this.
You are smart. But more importantly, the thing I care about most is that you work hard. All right. Because working hard makes it seem like you're smart to other people. Yep. All right, so there are 1,000 options. So what were we really doing here? Let's say that n represents the options. Options for each choice. We'll just say options. And r is the times that it's been offered. Times offered. Then the equation of repetition allowed is, what is it? This was n times n times n. How did I do this? N to the what? N to the third. And there were 3 options here. This was 3 times, which is r. So instead of putting 3,
Oh, R. And R.
It's 10 cubed. Woo.
n to the power of r. Yeah, so here's your formula. N to the power of r. N to the power of r. Write it down. Unfortunately, we won't be using this until later. This is not going to be used for the homework, but it is the really, really easy questions. Just n to the power of r.
Because they are exponential.
So it is exponential, yeah, depending on what your variable is, I guess.
You got me on.
All right, so those are the 3 key facts for this formula. This formula, n to the power of r, n is options, r is times offered, and repetition is allowed, and order matters. Why does order matter? Keeping you on your toes. Look at your very top definition.
Because it's permutation.
There it is. It's permutation, not combination.
Permutation.
All right, let's talk about repetition not allowed. All of your homework is based on this second category because
Yes.
these are the harder types of questions. Repetition is not allowed. So I'm going to choose a race. I could have chosen lock, pin, line, timeline, whatever I want, but I chose a race. So there are 12 runners in the race. We happen to have 12 freshmen. Imagine there are 12 of these freshman people, these desks. Those freshmen are running in a race. The top 3, gold, silver, bronze. How many ways can those 12 people place? So let's assume that this is the place. You can get first place, you can get second place, or you can get third place. How many options do I have for first place?
12.
12. There are 12 runners. But now first place has been decided. One of those 12 was chosen.
So it'd be 11 over 2.
Well, it's not over 2. This is just a title. It's like in quotes. There's no fraction here. It's just a number.
So it'd just be 11.
11? Yeah, let's make that note here. This is not a fraction. Oh, what am I doing here? I'm changing wrong color. These guys are not fractions. Not fractions. Maybe I should have done boxes so that they weren't confusing. Yes, there are 11 options for second place, and how many options for third place after first and second have been decided? 10. So the possible runners are 12 times 11 times 10, which is, do you guys know the trick for multiplying by 11?
It's going to be 1,210.
Nope. Close though. Whenever I multiply by 11, for example, 12, I'm making it nice and big, 12 times 11. Whenever you multiply by 11, separate the digits, add them, 2 plus 1, put it in the middle. Boom. 132 is the answer. You want to try another times 11?
10.
10 times 11, sure. 1 plus 0. 110, okay. That was easy, though, because you could have just added the 0. Let's say we had 25. 25 times 11. What is that?
That's gonna be 275.
275. There it is. You guys are
That is
killing
so
this.
cool.
Yeah, it's a fun roll, and it works with even really big numbers. That here's a hard one. Are you ready for this?
Yeah.
47 times 11. Oh, what are we gonna do? What are we gonna do?
That's gonna be 4,000 and
4 and 7. I separated them. What's 4 plus 7?
11. So it'd be 4,117.
So like that. Careful here. That's way too big. Way too big. It shouldn't be bigger than 1,000.
Why?
Well, because you're just basically multiplying 10 times 10. Like that's 100. You can't get over. You can't get over 1,000. Here's the trick. This tens place gets added to this place.
So it's gonna be 517.
517. Ready for this? 47 times 11. Boom! 517. Yeah! All right. So that's the trick for multiplying by 11. So now that you know that trick, and you'll remember it for the rest of your lives, 12 times 11 is
132.
times 10.
1,320.
Just add the 0. Yeah, there it is. That's the answer. Isn't that crazy? That's a huge number. With just the freshmen, our 12 freshmen running a race, there are 1,320 ways that the top 3 places can be decided. That's a ton of ways.
That reminds me of like from the movie of the Avengers: Infinity Warfare, when Doctor Strange was trying to find how many ways the Avengers would win. And
Yeah.
it was like one out of like probably wasn't it like 14,000 something?
Wasn't it in the millions?
Or sorry, I think
It was, yeah, some giant probability of not happening. Which honestly isn't that hard to get a big number once we realize how big probability gets. Like factorial is a huge multiplier. Anyway, what were we really doing here? I need to somehow get to a formula. What we were really doing here was we were doing 12 times 11 times 10. And here's the hidden part. Are you ready for this? You're writing this down with me.
Yeah.
Rochelle, you're writing this down with me instead of doodling on the whiteboard. 12 times 11 times 10, write this on the side. You're really doing times 9 times 8 times 7 ...
What?
And you were dividing this by 9 times 8 times 7
Why
times ...
9?
Yes! That is the question I was hoping you would ask. Why 9? And here's...
Wait.
Because it's not.
Wait. Is it because 1 plus 2 times 3?
No. But good guess. So, what is this top thing equal to? What is this 12 times 11 times 10? What is this thing?
I see what.
Okay, well, before you get to your answer, what is this thing? 12 times 11 times 10 times 9. This is represented by something factorial.
12 factorial.
Daisy, do you see why this is 12 factorial?
Yes.
All right. The thing on the bottom, what is this thing?
9 factorial.
You're really doing 12 factorial divided by 9 factorial to get 1,320.
The heck?
What the heck? I know. Okay, where did this 9 come from? That's the question that Rochelle is already asking.
I think I know.
Because of the 3 placements.
Yeah.
3 placements and the fact that we're... So 3 and what other number? 3 and...
3.
Well, 3... How do you get to 9 from 3?
12 minus 3.
There it is. What you're really doing was you're doing this number minus the top 3 places. So really, if n represents the total possibilities, well, what do we say up here? The total options, we'll just write options here. There are 12 runners, so there are 12 options. Do we agree with this? N was 12. There are 12 runners, 12 options, n was 12. We agree with this.
Yes.
So that means we had n factorial. Well then, you said 12 minus 9, so 12, well, not 12 minus 9, 12 minus 3. What was 3?
The third place. Right?
What was 3 in terms of n and r?
Oh, R.
R. And what does r represent again?
Times.
Yeah.
Upper.
This is the times, the number of places that you're looking for. We did 3 times because we had first, second, and third. There are 3 things that we were looking for. 3 times 3 things, maybe, if you want to say things.
So it's n factorial over n minus r.
N minus r, in parentheses,
Raise it. Oh, factorial.
factorial. You just derived a really hard to understand formula. This formula, write it down here again, it's n factorial divided by n minus r factorial. All right, so you know how I am about formulas, and I know how you are about formulas. You like formulas, I don't. Every single time, I always do it this way. Well, what makes sense? Well, there are 3 things I'm looking for. How many are this way? Okay, then -1, then -1. I do it this way every single time. I expect you to do whatever is easiest for you. I can see you doing a formula. You'll get it right every single time as long as you know how to use the formula, or you can just use logic. There are so many ways to do combinatorics, which is really what we're doing here. This is under the mathematic umbrella called combinatorics. You have algebra 1, you have precalculus. Underneath the umbrella of precalculus, there's a smaller umbrella called combinatorics. That is what we're working on. So combinatorics has many ways of solving it. Logic, formula, there's also a few other ways, but I'm not going to talk about them yet. So with this formula, we know what n and r are. We know what n and r are. No repetition and order matters. Order matters because, Daisy, why does order matter? Because it's a permutation. Why is there no repetition? Because of what we decided. We decided that there's no repetition. So let's apply all of this knowledge, specifically.
Oh my god.
Yeah, well, I guess we're going to be doing both of them. Let's do example 1. Permutation.
Oh god, permutation.
Like a mutation, permutation.
Permutation.
Yep.
Okay.
All right. So cryptex. Do you guys know who created the? Well, he didn't create the idea of a cryptex, but it's the who was the one that made the cryptex popular.
Oh.
It was an author. It was a movie.
Oh, I know the
James
movie.
Bond. I'm just kidding.
It was a book. It was a movie.
Wasn't it about like during a war and then trying to find like?
Not a war.
I don't know.
Forgot.
I think you were thinking of the Imitation Game with Benedict Cumberbatch, where they're doing the cryptography, stuff like that. You were probably thinking of, what was the machine that they were trying to crack in the Imitation Game? Type in Imitation Game.
Oh yeah, I was thinking of it. So in 1939, newly created British intelligence agency
Oh, the agent.
to crack Nazi codes, including Enigma.
Enigma, yeah. So Enigma was the name of the device. It was like a typewriter, but cooler because it had a bunch of cords and stuff coming out of it. This is not that. Anyone know what the cryptex, or who made the cryptex famous? Guy by the name of Dan Brown. He wrote a book called The Da Vinci Code. It's made into a movie. Spoiler alert, the answer was...
Shut up.
Oh.
Oh, Mr. Snow, I'm so sorry.
Wait,
I
do
did
you-
not mean to say that.
You do not want to know the answer? That's
No.
fine. You'll get it at the very end. The hint was Newton. It was very important to Newton. And it's in... It was only 5 letters, not 6 like this. But this is a cryptex with 6 letters. In the Da
I've
Vinci...
seen this before.
In the Da Vinci Code, it was a 5-letter cryptex. This is a 6-letter cryptex.
And the letters are in the picture, huh? And the Mona Lisa?
I don't think so. Mona Lisa doesn't really have letters.
Mona Lisa?
Numbers.
It's connected to the
Oh.
Mona Lisa, for sure. So, how many possible permutations are there for this cryptex shown above? Well, how many different little scrolly wheel things do we have?
6.
6. So we have 6 blank things to fill in. Let's do boxes. 1, 2, 3, 4, 5, 6. We have 6 different things where we have to figure out what goes in each of these 6 blocks. And then how many options go in each of these boxes? Well, how many letters are in the alphabet? These are in our normal alphabet. Is it Greco-Roman alphabet? Is that the correct way of saying it? Mr. Elliott, yep, nods her head. So in the Greco-Roman alphabet, how many letters do we have? 26. There it is, 26. So we have 26 options for the first box. What about for the second box?
26.
26. So third box.
Same thing.
Same thing, same thing. We're really using our formula, which is what?
And factorial.
Nope. Order, repetition is allowed. I can have this, the code could have been A. We could have had repetition. It's allowed. Repetition is allowed. So repetition is allowed, which means we're up here with this formula. Oh, I don't know what happened there. N to the power of r. So what to the power of what do I write here?
Are you kidding me?
26.
To the power of 6, yep. 26 to the power of 6 is, 26 to the power of 6 is, no, 26 to the power of 6 is 308,915,776. Write it down. 308. So this is equal to 308, 915, 776. 7, 7, 7, 6. There is a reason why it's hard to break a cryptex, because there are a lot of possibilities. Granted, it's probably going to be a word, so it's going to be narrowed down. Is not going to be an answer. Neither is Z, X, Q, Q, Z, Y. It's probably going to be a word, but still, that is the total number of possibilities it could be. By the way, I could totally 3D print one of these if someone is interested in.
You should definitely do that. I agree.
I've been wanting to do it for a while. It just takes forever to print out. All right, let's do example 2.
Just find the colon.
How many unique ways are there to spell Sindel? So the letters. How many letters do we have?
6.
6. Are any of them
Letters.
repeated? Are any of these letters repeated?
No.
So there's no repetition. Would you agree?
Yeah.
So if there's no repetition, repetition is not allowed, we are with this formula right here. Or you can just think about it logically. So what do you want to do? Do you want to use formula or do you want to use logic? Logic. Okay. So I need to have 6 letters because Sindel has 6 letters. So there are 6 spaces. 1, 2, 3, 4, 5, 6. How many choices do I have for the first place? How many different letters can I choose from? I can choose 6. But now I've chosen a letter, and I can't use that letter again, so now I have 5, 4, 3, 2, 1, which is really 6 factorial. Calculate that by hand because you don't need a calculator. By the way, we already figured out that 5 factorial is 120, so you really need to multiply 120 by 6, and you're done.
72.
72 with a 0, yeah, 720. 720 ways.
How would you do it with the equation?
Let's do it with the equation. Let's do it on the side. So, what is n?
6.
N is equal to 6. And what is r?
The options.
The time is offered.
Oh, times offered.
Which doesn't really say how many times offered.
Well, it's offered 6 times because there are 6 boxes,
so
right?
it's 6 minus 6?
Yep. So, using the formula, it's 6 factorial divided by 6 minus 6 factorial. This is the reason why I defined earlier that 0 factorial needed to be 1, because now I have 0 factorial on the bottom. So the answer here is 6 factorial over 0 factorial, which is really 6 factorial divided by 1, which is really 6 factorial, which is what we just did, 720. So the formula works. Sounds good? Now let's use the formula on something that a little bit needs it more. All right, we're on it to example 3. Who wants to read?
On their quest to Madol are Frodo, Sam, Merry, Pippin, Aragorn, Boromir, Legolas, Gandalf, and Gimli. And how many ways are there for the 9 companions to arrange a team of 4 to be sent in a single
Can I just say Frodo pisses me off all the time? Stupid.
He's pretty cool in the books.
I like him, but
Did you guys read the books? You girls read the books?
I read like half of it, but
I have the audiobooks if you guys want to borrow them. The books are way, way better than the movie. Obviously, there's a ton more in them, and they make a lot more sense, and you don't get nearly as bad as at Frodo. Everything is pretty understandable. Gollum doesn't really trick him in the way that he does with the movies. I highly recommend the books. They're popular for a reason.
I had the VCR thing, and I
Wait,
had to
can
get
you
like
send
2
me
of
that?
them to watch the whole
Online?
Yeah.
Yeah, for sure.
The audiobooks.
All of them? All right. You can't, don't sell it, don't repurpose it. You can borrow it and then give it back. All right. So, I need to arrange a team of 4, and it matters what order, or does it? Think about this. Does it matter for the order?
Team of 4. No. Oh, single file.
Then, yeah.
Well, think about this. Does it matter if Gandalf leads or if he's in the middle?
And,
No.
yes.
It kind of matters because Gandalf has the light for his staff, so it matters that he's in the front. So it's kind of iffy. It's not quite clear, but I'm going to tell you, it needs to be, if you see the word arrange, underline it in your notes now. If you see the word arrange, it means order does matter because, like, I can't put maybe Aragorn next to Boromir because they're both humans and they both want to kill each other for some reason. They both think they're going to be the king.
I didn't really get that, though. Why
Um,
do they actually really want to kill?
so Boromir is the favored son of, oh God, it's been so many years, of that guy that ruled over that white Minas Tirith. And So Boromir always thinks, even though he's technically like a servant to whoever's going to be the next king, they always think that the kings are all dead. So Boromir's like, I'm going to be the one that's basically the king, but if there's a king that comes along, then I'm going to have to serve him. Aragorn is actually the secret king, so they're kind of fighting for who's going to be in charge of Minas Tirith and all that. That was a probably horrible summary, and I'm sorry to anyone watching the video if I have offended anyone. That's what I remember from many, many years ago. So, and I'm basing that off of the books, not the movie. I forget what happens in the movie. So arrange. How many little boxes am I making? Definitely 1. 9 or 4?
No, wait.
One of them is correct. 4? Are you sure?
I don't know.
Well, I'm arranging a team of 4, so yeah, I have 4 boxes. That's my team. There's my team. Who's going first? Hopefully it's going to be Gandalf because he has the light, he can actually see. Or maybe Aragorn, he's really good at tracking. Legolas is light-footed, so maybe if we get trapped in the snow like it happened in the books but not in the movie, then he goes out front. Anyway, so how many different ways can I choose the first person in the line? Of the 9 companions, how many can I choose from?
I have 9.
9, yeah. There's 9 people that can be the leader. How many people can go second?
So 8.
8, then...
7.
Then,
6.
yep. So, and then we don't have any more because that's the team of 4. Okay, so multiply these together and you get your answer. So here we go. Calculator, pull it out. 9 times 8 times 7 times 6. 3,024 ways. 3,024 ways. So hopefully they don't argue about who goes where because they are going to have a lot of different ways to arrange their team of 4. All right, you want to use the formula to see if it works? Sure. Okay, so what is the top number? What is n? What is r? N is equal to, r is equal to?
N is equal to 9.
9. We have 9 options, I agree. And how many places do we have?
4.
We only have 4 places to look for. Okay, so I do 9 factorial divided by what?
5.
5 factorial, because that's 9 minus 4 factorial. 9 minus 4 factorial. So that's going to be 9 times 8 times 7 times 6 times 5, blah, 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 all divided by 5 factorial, which is 5 times blah, 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 blah. Those all cancel each other out, and it's just 9 times 8 times 7 times 6, which is what we got. Looks good? Everything matches up? Any questions? This is the one time in our notes where I totally did not even copy off of Khan Academy. Khan Academy uses arranging reindeer in a line. You have Dasher and Dancer and all of them. So they're arranging reindeer, and they're, I guess I kind of did steal it from Khan Academy. How many unique ways are there to spell a certain word? None of the words that are on tonight's homework have multiple letters because I haven't taught you how to do that. What if instead I wanted you to arrange the letters of Daisy? Daisy has 2 A's in her name. Well, that changes the probability that it's going to be arranged, or it changes the number of ways you can arrange it because you have repetition, but some of the time. So we haven't talked about how to do Daisy's name yet, but all of the words that have just individual letters that are not repeated, you know how to do that. That's going to be on the homework. So that concludes the lesson. Go ahead and write your summaries, and then the homework is already posted on Khan Academy.